Okay, so let's take all of the examples that we just did and let's kind of put them all together into a theorem. Now, I hope one of the things that you noticed was that the number of triangles we created was 2 less than the number of sides that the original polygon had. So for example, if we look at the quadrilateral, quadrilaterals have 1, 2, 3, 4 sides. But how many triangles did we create? 2. Let's look at a pentagon. Pentagon has 1, 2, 3, 4, 5 sides. But how many triangles did we create? 1, 2, 3. So we created 2 fewer triangles than the number of sides the polygon had. So we're going to take that, and then what do we do with that number of triangles? Well, we multiplied the number of triangles times 180, because that's the sum of the angles of a triangle, and that's how we got the sum of the interior angles of the polygon. So now let's capture that into a formula, and it looks like this. The sum of the measures of the interior angles of an n-gon, in other words, a polygon that has n sides, is n minus 2 times 180. So here, n is equal to the number of sides of a polygon, and we subtract 2 from that, we multiply by 180, and we get the total of the sum of the angles of the interior, the sum of the interior angles of the polygon. Okay, so we might write something like angles, or sum of angles equals n minus 2 times 180. Okay, that's our formula. That's what we got. So questions over here on the left. What's the formula to find the sum of the interior angles of a polygon? Or how about, how can you find the sum of the interior angles of a polygon without using a formula? And this formula is important because it makes life a little easy for us, but if we can't remember the formula, always go back to the idea of creating triangles in your polygon. Every triangle's angles add to 180, so if we know how many triangles we have, all we have to do is multiply that by 180. All right, let's do a couple of example problems of how are you going to use this information. Example 1, let's find the measure of angle y. So here we have polygon TRMYV, and what I want to know is what is the measure of angle y right here. Okay, so the first thing I'm going to look at is how many sides does this polygon have? Well, let's see, we've got TR, RM, MY, YV, and BT. So we've got 1, 2, 3, 4, 5 sides. That means that the sum of the angles, I'm going to use my formula, n minus 2 times 180. What am I going to plug in for n if there's 5 sides? I plug in 5. So the sum of those angles is going to equal, if we look at this part, 5 minus 2 times 180. So measure of t plus r plus m plus y plus v is equal to 5 minus 2 times 180. So now let's simplify that a little bit. 5 minus 2 is 3. 3 times 180 is 540. So that's here. So again, angle r plus, or angle t plus r plus m plus y plus v is equal to 540. Now let's plug in the measures that we actually know. Angle t is a right angle, V is a right angle, and M is a right angle. So those all have measures of 90. And then measure of angle R is 135. So let's plug those measures into my equation here. So now it's going to look like 90, measure T, plus 135, plus 90, plus the measure of angle Y, which is the one that we don't know, plus another 90, that's V, is equal to 540. Now we just collect our like terms and simplify. 90 plus 135 plus 90 plus 90 is equal to 405. So 405 plus the measure of angle y equals 540. So again, since I'm solving for the measure of y, I subtract 405 from both sides, and I'll end up with my result. The measure of angle y is equal to 135, which is interesting. It turns out to be the same as the measure of angle r. Okay, great. So now let's look at another problem. This was numerical, right? We had numerical values for all of the angles, but let's look at an example that involves a little bit more algebra. Here, let's solve for x and y. So we can see x is right here, y is here, here, and here. Okay, well I have more y's than I have x's, but it might actually be easier to solve for x first. I notice that this is the only place where x is, and I have an exterior angle here. Together they form a straight line, so what do these two angles have to add up to? They have to add up to 180. So before I even think about dealing with y, I'm going to solve for x. So my equation there is going to be 112 plus x equals 180 because they form a linear pair or a straight angle. So subtracting 112 from both sides gives me the value x equals 68. So another thing that I like to do is go ahead and put that in my figure. Once I figure out what x is, go ahead and label that in your figure. So there's 68 degrees. I don't care about x anymore because I already know it is 68. So just for the sake of the picture, we'll scribble that out. Now we know that that's 68. Awesome. Okay, so now let's talk about how do I find y. Well, to find y, I really don't care anything about this part of the picture because all my y's are inside. All I care about is the polygon that we see here. This polygon has 1, 2, 3, 4 sides. So since I know how many sides it has, I can find the sum of its angles. So the sum of the angles of that polygon is going to be, there's 4 sides. So the sum of the angles is 4 minus 2 times 180. That's 2 times 180. That's 360. So all of these angles here, 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 and here have to add up to 360. So that's my equation. So let's set it up. 68 from here plus y plus 10 from here plus 2y plus 5 from here plus y minus 15, that last angle, all 4 of those together must add to 360. So the next thing I need to do is combine like terms. We have y plus 2y plus y. So that gives me a total of 4y. Then we have 68 plus 10 plus 5 minus 15. So 68 plus 10 plus 5 minus 15 actually ends up to be just 68. So now we have 4y plus 68 equals 360. Subtract 68 from both sides. That leaves me with 4y equals 292. And then to undo this multiplication, we divide. So we have 4y divided by 4 equals 292 divided by 4. Well, 4 divided by 4 is 1. That's what we want. And 292 divided by 4 is 3. So now we have y equals 73. And we've got our two solutions. X is equal to 68. Y is equal to 73. Awesome. Okay, now let's continue what we were talking about with the angles of polygons. Let's talk about the exterior angles. I've got 4 polygons on the screen here, and what I've done is I've created the exterior angles by extending each side in one direction. So for my triangle, my exterior angles are here, here, and here. For this quadrilateral, my exterior angles, of course, are here, 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 and here. Now notice, for my quadrilateral, I have 4 exterior angles. How many sides did I have? 4. There's a direct relationship there. If I have a pentagon, which has 5 sides, I have 5 exterior angles. If I have an octagon, which I have here, I have 8 exterior angles. 1, 2, 3, 4, 5, 6, 7, 8. And what we want to do is figure out, well, what do all of these exterior angles add up to? Now, I want you to look carefully at the size of these angles. When I had a triangle, each exterior angle was pretty darn big. In fact, if you look at it, you can see that each one is obtuse for this particular triangle. So here I have 3 big angles. I'm going to write that down. 3 big angles. Now what's happening as the number of sides increases? So here I have 4 angles. And the way that I've drawn it, I've kind of drawn it so that it looks like a rectangle. So it looks like each exterior angle is about 90 degrees. But let's go ahead and look at the pentagon next, right? We've got 1, 2, 3, 4, 5 angles, but look at each one of these angles. Each one of them is acute. So I have five angles, but they're all a little bit smaller. Now let's look at the octagon. Look at this. My angles are even smaller yet. So even though I have more of them, they're actually all smaller. And this actually leads to a really interesting thing in that the sum of the angles of any type of polygon you have, the sum of the exterior angles is always the same. So what we had here was 8 small angles. And it turns out that the sum of these 3 big angles is the same as the sum of these 8 small angles is the same as the sum of these 5 kind of in between size angles. So you can see as we get more sides, those exterior angles become even smaller and smaller and smaller and smaller and smaller. But there's more of them. So it turns out that the sum of the exterior angles of any polygon is 360 every single time. So we might write that again. Sum of exterior angles equals 360 always. I don't care how many sides it has. Sum is always 360. So question on the left, what's the sum of the exterior angles of a polygon? There we go. So now let's use this in an example. Let's say we want to solve this for x. How many sides does this figure have? Well, let's see. It has 1, 2, 3, 4, 5 sides. Do I care? No, because I know that the sum of the angles is equal to 360 no matter what. And all the angles that I've been given here in this diagram, they're all exterior angles. Okay, so my equation that I'm going to set up is going to be the sum of those angles, where we have 2x plus 3x plus 5 plus 2x plus 10 plus x minus 15 plus 2x minus 20. All 5 of those angles add to 360. So now we just have to solve this equation. So first let's combine our like terms. 2x plus 3x is 5x, plus another 2x is 7x, plus x is 8x, plus another 2x is 10x. Then we have 5 plus 10 minus 15 plus 20. That all adds to 20. So we have 10x plus 20 equals 360. Subtract 20 from both sides. We have 10x equals 340. Divide both sides by 10. 10x divided by 10 is just x, and 340 divided by 10 is 34. So x is equal to 34. And we're done. So in class on Monday, we'll talk a little bit more about how to apply these two theorems, the sum of the interior angles and the sum of the exterior angles. And then we'll also talk about how to apply them to what we call regular polygons.